in decimal number system, we use 2 digits. It is not anymore 1 digit enough. So we have to use another digit to express the numbers greater than 9. We combine those digits, and the digit on the left shows units, and the other digit, in this case the number 4, the digit 4, shows tens, as you know. So if we want to write the number 47, we should write, we divide, we separate the digits if we want, and we can write 47 is equal to 4 times 10, 4 times 10 plus 7 times 1. So 4 tens, and 7 ones, isn't it? So you know this, isn't it? So, but we can continue with hundreds, thousands, etc. by shifting by 1 position due left each time. So if we want to write 569, we write 500, 6 tens, and 9 units, or 9 ones, we can say otherwise. Now let's start to speak about the binary system. The binary system is made up only by zeros and ones. It is not like our or decimal number system that is composed from 10 digits, from 0 to 9. The binary system recognizes only numbers from only zeros and ones. So this is a binary number. This is the example of a binary number. In this binary system, there are no 2s, 3s, 4s, 5s, etc. Are only zeros and ones, only 2 digits.
If you are known, you are trying to now that
in ACT, you know that in ICT, you know that is a single binary digit, either a 0 or a 1.
They say just wash.
Binary numbers have many uses in mathematics and beyond. So, in fact, in digital world, in computers, in mobile phones, etc., we use only binary digits. A computer recognizes only zeros and ones. A computer does not recognize 2s, 3s, 4s, etc. Let's start to explain how do we count using the binary system. It is just like counting in decimal, except we reach 10 much sooner. So in the binary system, when we reach 10, we express the number in 2 digits. Here, when we reach 2, we express the number in 2 digits, not in a single digit. Let's give some example. In the binary system, 0 is still 0. 1 means 1. But if we want to write the number 2, we cannot write 2 in the binary system. So we should write, we will do like this. In the decimal system, we have 0. We start at 0. We have the number 1, 2, 3, etc. up to 9. And then when we want to write the number 10 in our system, we start back at 0 again in the units, but we write 1 in the tens. So we write 0 units and 1 10. In the binary system, it is the same thing, but the next position is not after we want to write numbers greater than 9, but greater than 1, 2 and up. So we start from 0. Again, in the binary system, 0 is still 0. 1 in our decimal system is still 1 in the binary system. But if we want to write the number 2, we can write 2 anymore. We should write 0 on the left, on the right, and 1 on the left. There is some noise, please. So it is 0 in the position of ones and 1 in the position of twos. What does it mean? We have 0 ones and 1 2. So 2 and 0 is 2. If we want to write the number 3 in the binary system, we have 1 1 and 1 2. So we should write 2 ones here. And we continue with other numbers. If we want to write the number 4, the number 4 has 0 ones, 0 twos, and 1 4. So we should write 1 0 0 because we start from the right to the left counting. These are ones, these are twos, these are fours, etc. Sorry, there is some noise. Could you lower the voice, please? What happens in decimals? When we have 99, we write only 2 digits, 9 in the position of ones and 9 in the position of tens. So this number means 9 times 10 plus 9 times 1. But if we want to write 100, we can write 1 times 100 plus 0 times 10 plus 0 times 1. Isn't it? So we start again at 0. This is the position of units. This is the position of tens. This is the position of hundreds in our system. The same way is as well for the base 2 number system as well. We start from 0. If we want to write the number 0, we start from 0. If we want to write the number 1, we can write only 1 in the binary system because it is 1 times 1. If we want to write the number 2, we have 0 times 1 plus 1 times 2. So 1 times 2 is 2. 0 times 1 is 0. So we have the number 2. This is like if you speak in another language. You speak in your own language. Let's suppose that the decimal system is your own language, but you want to speak in French with somebody else. So you have to write the similar word, the word with the same meaning, but written in another way with other letters. So in these two systems, there is the same thing. So instead of writing the number 2 with the digit 2, as in our decimal system, we write it 1 0 because the digit 0 shows the units, the ones, and the digit 1 shows the twos. Because in our system, we start numbering 1 times 10 becomes 10. 10 times 10 become 100. 100 times 10 become 1,000. 1,000 times 10 become 10,000, and so on. But here we start numbering from powers of twos, not powers of tens. So we have ones, we have twos. 1 times 2 become 2. 2 times 2 become 4. 4 times 2 are 8. 8 times 2 are 16, and so on. those are similar to our tens, hundreds, thousands, etc. If we want to represent the number 3, the number 3 in our decimal system is written in the binary system 1, 1, because we have 1 times 1, 1 units, and 1 twos. So 1 times 1, we get 1. 1 times 2, we get 2. So 2 and 1 are 3, isn't it? So if we want to write the number 4 in the binary system, we have 0 ones, 0 twos, and 1 4, because the third position starting from the right is the position of 4s. The first position is the position of 1s. The second position is the position of 2s. The third position is the position of 4s. The fourth position is the position of 8s. The fifth position is the position of 16s, and so on. The sixth position is the position of 32s, because we multiply by 2 each time we want to add 1 position on the left. So if we want to write the number 4, we write it as 0, 0, 1, starting from the left, from the right, sorry. So 0 ones, 0 twos, and 1 4. And it is our number 4, the normal number 4. If we want to write the number 5, what do we have? 1 unit, 1 1, and 0 twos, and 1 4. So 4 and 1 are 5. This is 6. 0 ones, 1 2, and 1 4. 1 times 4 is 4. 1 times 2 is 2. 4 plus 2 are 6. And so on. So how the powers of 2's are written using the binary system. If we want to write the number 1, we simply have 2 at power 0. Every number at power 0 gives 1. So we simply write only 1. If we want to write the number 2, 2 is 2 at power 1. So we write it as 0, 0 ones, and 1 2, as I said before. If we want to write 128, what does it have? This number is 2 at power 7, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 are 128. So we have 2 at power 7. In this number, we should write all zeros, only the digit on the left will be 1. But we start from the units, not from the 2's. So we should write not 7 positions here, but 8 position, because the first position on the right shows the units, the ones. We start counting powers from the power 1, not from the power 0. Or if you want, you can start like this, from 0. 0, 1, 2, 3, 4, 5, 6, and 7. So you should write 2 at power 7 with 8 positions here, with 8 digits. The first digit on the right shows units. It shows, the second one shows 2's, the third one shows 4's, 8's, 16's, 32's, 64's, and 128's. All the other numbers are zeros, except this one, because 128 is exactly 2 at power 7. So only this number should appear in the base 2 number system. All these numbers should be 0. If we want to write 129, this number will be 1000000 and 1. So this one is the unit, only the unit that was added to 128 to give 129. And all the other numbers are 0 except the first number, which shows 2 at power 7. So let's compare the decimals and binaries in this table. In the decimal, we have 0, which is 0 in the binary. 1 is still 1. The number 2 in the decimal system is 1 0 in the binary system, because we have 0 ones and 1 2, so only 2. The number 3 is 1 1, one unit, or 1 1 and 1 2, so 2 plus 1 are 3. The number 4 is 1 0 0, because we have 0 units, 0 ones, 0 twos and 1 4 here. So we write this number like this. For example, the number 15. In the number 15, we have all ones here. Why? Because we have 1 unit plus 1 2. These two become 3. 1 4. 3 plus 4 are 7. And 1 8. 7 plus 8 are 15. Let me see your face here. I want to stop sharing for the moment. I'm trying to understand if you are following me. Do you understand me so far? Am I clear?
Yes.
Am I clear, or do you have any question? So basically, in the number 2 systems, we use only zeros and ones. We don't use 2, 3, 4, etc. The similarity with our number system is when we are trying to when the first range of values is filled, and now we have to write the other range of numbers, the tens, 100s, the position of tens in the second place on the right. The first position, the units are on the first place on the right. The third position, the hundreds in our system, are the third position on the right, and so on. In the binary system, this occurs by powers of 2, not by powers of 10. So when we have the powers of 2 filled, we continue with the other positions as well. Let's see a table here. This number, this position here shows ones. This position here shows twos. This position here shows fours, or 2 times 2. As in our numerical system, that is 10 by 10, 10 times 10, 100. The fourth position, starting from the right, shows the eights, and so on. But we can also write the decimal numbers using the base 2 number system as well. So the first position after the decimal point shows halves. 1 over 2. 1 over 2. 1 half. The second position after the decimal place shows 1/4. Quarters, not halves, quarters. The third position shows 1 over 8. 1/8, and so on. So when we shift from the right to the left, the numbers become 2 times bigger. When we shift from the left to the right, the numbers become 2 times smaller. They decrease by a factor of 2. So this is, if we want to write a number 13.6 625 in decimal. If we want to write in the binary system, we should write it 1/8 plus 1/4, they are 12, plus 0 2s and plus 1 1s. So we have 1 1 0 1 because this is the position of units. We have 1 unit plus 0 2s plus 1 4 and 1 8. 8 plus 4 are 12, plus 0 plus 1 are 13. So this is 13. This is the half, the position of the half. This is the position of 1/4, 1/4. This is the position of 1/8. So we have, after the decimal point, we have 1/2 and 1/8. So 1/2 and 1/8, if we add one, write them as a decimal, we can write 625 in the decimal way, in the decimal form of representation. So numbers can be placed to the left or right of the point to show values greater than 1 and less than 1. So all these numbers are greater than 1. This number is smaller than 1 when we want to write this number as a decimal. What kind of number is this? This is 2.5 in the decimal system. Why? Because this position shows the units and this position shows the twos. So we have 2, here we have 2, here we have the half after the decimal point. So we have 2.5 in the decimal representation. The word binary comes from bi. This means 2. So binary system is the system of numbering with base 2. When we say a binary number, we pronounce each digit. We pronounce each digit. Example, the binary number 101 is spoken not 101 as in our decimal system, but 101. We should pronounce each digit separately in the number 2 system. 101 or 101. A single binary digit like 0 or 1 is called a bit. In ICT, the computer recognizes only zeros and ones. Every set of numbers like this presents a symbol or a letter.
For example, 10010 is 5 bits long.
How to show that the number is binary? We can write the base 2 in the bottom right part of the number to show that we are not speaking about 101 in our decimal system, but 101 in base 2. So we should write the base 2 here to demonstrate that we are speaking about the binary numbers, not the decimal numbers. Let's see some examples. What is the number 1111 with base 2 in decimals? What should we do now? The first one on the left shows the 8s. 2 times 2 times 2. The second one shows the 4ths.
Look,
this one shows the 2s, and this one shows the 1s. So we have 1 times 8 plus 1 times 4 plus 1 times 2 plus 1 times 1. So we have 8 plus 4 plus 2 plus 1. So totally we have.
Write it as example. What is the binary
in the decimal
system? What is 1112 in decimal?
The decimal system
The one on the
recognizes
left
digits
is in
from
the
0 to 9. We can write 1, 5. But in the binary system, we cannot write 2, 3, 4, etc. We should write only zeros and 1. That's why the number 1111 at base 2 is equal to 15 in base 10. We do not need to write the base 10 here, but if you wish, I can write it just to show you that I'm speaking, I'm referring the decimal number system. Usually the base is not written in our system of numbering in the decimal one, but if you want, we can write it, no problem. Here we should write, it is important to write the base 2 in this system of numbering to make distinction between the number 15 and the number 1111 in the decimal system. So it is very important to write the base here. Another example. What is 1001 with base 2 in decimals? We have the units here, the 2's here, the 4's here, and the 8's here. So we have 18, 04's, 02's, and
attend to what you're writing.
So we have 8 plus 1, we have 9 in the decimal system. Do you understand? Do you understand? So, let's explain again. The one on the left shows the 8's, or 2 times 2 times 2. Because we start from 0 here, 0, 2, 2 at power 1, 2 at power 2, 2 at power 3. So we have 2 at power 3, 2 at power 2, 2 at power 1, 2 at power 0. We can write this number like this. 1, 0, 0, 1 at power 2 is equal to 2 to 1 times 2 at power 3 plus 1 times 2 at power 2, no, 0, this is 0, the second one, plus 0 times 2 at power 1 plus 1 times 2 at power 0. But we know that 2 at power 0 is equal to 1. We know this one. 2 at power 1 is equal to 2. 2 at power 2 is equal to 4. 2 at power 3 equals 8. That's why we can write this number in this way to understand better. So we have equal 8 plus 0 plus 0 plus 1 or 9. The result is 9. Do you understand?
Yes.
Let's see a decimal number, 1.1 at power 2. This number represents ones. This number represents halves, so we have 1.5 here. This number represents 1 divided by 2. If we have another number here, we would have
So that means 1.
this one is 1 divided by 4,
Why this one?
and so on.
The half space.
Hello.
Hello.
During the class. Hello. Okay.
The number 1 in the 2's position. So this means that 1 times 2, we have to solve another exercise. What is this number in the decimal? Example, another example. This number shows the ones. This number shows the 2's. So we have 2 here, 2.5. This is a quarter. A half and a quarter are 3/4. So 0.75 after the decimal place. And so the number is 2.75 in the decimal system. Now, I'm going to show you how to convert the decimal numbers into numbers at power 2. How to convert a decimal to binary. I'm going to show you this one. Let's take the number 75. This number is to be divided by 2 every time. 75 divided by 2 equals 37, and the remainder 1. Do you know the remainder? If we don't have an exact division, but we have a remainder here, we can write it. If we divide 37 with 2, we obtain 18. The remainder is 1. I have the number 18 divided by 2. It is equal 9, exactly 9. The remainder is 0. If we have 9 divided by 2, this is equal to 4. The remainder is 1. If we have 4 divided by 2 equal to, the remainder is 0. If we have 2 divided by 2, we have 1. The remainder is still 0. And 1 divided by 2 equals 0. The remainder is 1. Now let's take these remainders here and write from the bottom to up, or from up to the bottom, but from the right to the left. So we have the number 1, 1, 0, 1, 0, 0, 1 with base 2 equal to 75 at base 10. Could you solve an example, please? I'm giving you 2 exercises. One exercise is convert the number, let's say 101110 at base 2 to base 10. This is the first example, the first exercise you have to solve. And the second exercise, convert 23 to base 2. 23 is at base 10. It's obvious, obviously. Could you solve these two exercises and show me only the result? I'm letting you 5 minutes time. You can write down the result in the chat box.